Energy, force and power, number 12. Now this time we have got a 200 kilogram box placed on a set of scales in a lift. This is the kind of thing that only happens in physics exams, never in real life. So we've got a somewhat modified version of the weight equation there to do this sort of problem. W is the weight in newtons, M is the mass in kilograms, G is gravity in newtons per kilogram. Could be meters per second squared. Remember, 1 meter per second squared is exactly the same size as 1 newton per kilogram. And then we've got A. A is the acceleration of the lift, or similar, because we can apply this to other situations. So let's have a look at part A. Part A says that the lift is stationary, so that means that the acceleration must be 0, so W equals M G plus A. The mass is 200, G is 9.8, A is 0. So those of you that have been paying attention in maths will know that this just collapses down to our traditional W equals mg formula. So that's going to be 1,960 newtons for part A. For part B, we're told the lift is accelerating upwards at 1.5 meters per second squared. That means that the weight that's read on the scales will be M G plus A, still 200 kilograms, 9.8 plus 1.5. The weight is now going to be reading on the scales as 2,260. Like so. Part C, well, part C, there is no acceleration again. So that means that our answer to part C is going to be the same as our answer to part A, because they both have 0 for the acceleration. Always put the units in. Do not forget the units. Naughty Mr. McCann. So that will be 1960 newtons. And then for part D, we're told in part D that the lift is decelerating upwards. And this is them trying to be funny with the language. In part B, it was accelerating upwards. In part D, it's decelerating upwards. So this time, A is negative 1.5 meters per second squared, because it's decelerating, but it's still going upwards. So this is where we really have to be careful with the vectors. Negative because it's decelerating doesn't necessarily mean it's not moving upwards. So, popping the numbers into our modified equation, (200 kilograms times 9.8 minus 1.5 this time, which should give us 1,660 newtons. Like so.